Hello students, welcome to ePhysics. Students, in this video we will be discussing about equations of motion. Okay? Now, students, equations of motion are also known as S, U, V, it will be V, A, T equations. Why S, U, V, A, T equations? Because S means in the equation that the three equations of motion that we will be studying, there S means distance. Okay, this U means initial velocity. This V means final velocity. This A means acceleration, and finally this T means time. So in the three equations of motion, we will be discussing about these five terms. Okay, we will be finding the relation among these five terms in the three equations of motions. Students, the three equations of motions are only applicable for the object which are in uniform accelerated motion. Okay, for uniformly accelerated motion. We can derive the equations of motions in three ways. One, it will be algebraically. Okay. The other, it is graphically. And the other by the calculus method. Okay. But here in this video, we will be discussing the derivation of the equations of motions algebraically. Okay, and in the next video we will be deriving the equations of motion graphically, and later on that in the this calculus method will be used for the higher standards like class 11th and on, but from the class 9th perspective the derivations are algebraically and graphically only in the syllabus. So here in this video, we will be particularly discussing about the algebraical derivation of the equations of motions. So let's begin it with the first equation of motion. Now, here the first equation of motion, how will we derive it? Students, in the previous videos, we have discussed about acceleration. And from the definition of acceleration, we have discussed that acceleration is the change in velocity per unit time. Okay, so according to the definition, acceleration means change in velocity divided by time. Students, earlier here we have discussed the final velocity is denoted by v, the initial velocity is denoted by u, and the change in velocity will be v minus u, that is final velocity minus initial velocity, and the time taken will be t. So here acceleration is equals to v minus u by t. This can also be written as at is equals to v minus u, and finally we can write it as, when we shift this negative of u on the left hand side, it becomes u plus at is equals to v. So there we get the first equation of motion from here. The first equation of motion is v is equals to u plus at. Okay, so this is the first equation of motion, and this is how we derive it. So now let's move to the second equation of motion. Now students, the second equation of motion. Okay, the second equation of motion. Now students, we have discussed that these equations of motions are only applicable for the uniformly accelerated motion. So here we can write that distance traveled, okay, distance traveled is equals to average velocity average velocity multiplied by time. Okay, and earlier in this video we have discussed that distance traveled is denoted by s is equals to average velocity. We know, we have studied in the earlier videos that it is the sum of initial plus final velocity divided by 2 and multiplied by t. Okay, and students, from the first equation of motion, we have been knowing that v is equals to u plus a t. Now, if we substitute this value of v, that is u plus a t, in this equation, we get, now if we substitute it, it will be equal to s equals to u plus, in the place of v, we can write this, that is u plus a t divided by 2 multiplied by t. Now, this can also be written as s is equals to this u plus u is equals to 2u plus at divided by 2 and multiplied by t, which can further be written as s is equals to 2ut divided by 2 plus a t square divided by 2. Now here we can cancel 2 each from the numerator and denominator. So finally we get a new equation, that is s is equals to ut plus 1 by 2 a t square. So this is the second equation of motion that we were discussing. So this is how we derive the second equation of motion algebraically. So let's move to the third equation of motion. Now we will be discussing the third equation of motion. The third equation of motion. Students, we have studied now only the second equation of motion, that s is equals to ut plus half a t square. Let us consider this as equation 1. And we have been knowing from the first equation of motion that v is equals to u plus a t. From this equation, students, we can write v minus u divided by a is equals to t. Let us consider this is equation 2. Now, if we substitute the value of t equals to v minus u upon a in the first equation, what will we get? Okay, so from equation 1 and equation 2, we get that s is equals to u multiplied by t, and in place of t we will be writing v minus u upon a plus 1 by 2 a t square. T का value is v minus u upon a का whole square. So finally, after solving it, we get s is equals to u multiplied by v. That is, if we solve it, okay, if we solve it, we get uv minus u square divided by a plus 1 by 2 a. Okay, now here, from here we can write it is v minus u ka whole square in the numerator, which can be written as a minus b ka whole square, which is equals to a square plus b square minus 2ab. Okay, divided by denominator ka square, that is a ka square. Here 1a and 1a gets cancelled. So we move to the conclusion here. Now here in the numerator, the LCM of 2a and a is equals to 2a. 2a divided by a is 2 and 2 multiplied by this numerator. Okay, so this can be written as 2uv minus 2u square 2u square, this plus 2a and 2a gets cancelled, so we are left with v square plus u square minus 2uv. Okay, here this is how we get this. Okay, now solving it further on, this is minus of 2uv and this is plus of 2uv. So finally we get to the conclusion over here that if we move this 2a from the denominator to the left hand side, we get it is equals to 2 into a into s equals to, here students we can clearly see we are left with v square, this is v square, and minus 2u square plus u square is equals to minus of u square. So this is what we call the third equation of motion, and this is how we derive the third equation of motion algebraically. So I hope you understand the video very well. In the next video, we will be deriving these three equations of motions graphically. So thank you very much for watching the video.